Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and this is the climax of financial mathematics in grade 11. Remember, if we look back at this whole chapter, we started with nominal versus effective interest rate, okay? Now, nominal and effective, where it was, by how much does an investment actually grow in a year? Effective interest rate. But then sometimes it's compounded monthly, quarterly, yearly. Then we went over to depreciation. Now, depreciation, we calculated the book value of a car or of a PC or of any piece of equipment. Then we moved on to timelines, where we did multiple investments as well as changing of interest rates. Now, sinking funds, ladies and gentlemen, is going to the application basically of all of this together with inflation you did in grade 10. So starting with a sinking fund, remember a sinking fund is to replace an asset in 4 or 5 years' time without having to take out a loan in 4 or 5 years' time. So I'm going to always start with a cost price. That's my starting point in all sinking funds. So how much does it cost now for me to buy that asset? Then it's going to grow, meaning the price is going to grow over time. Well, because things become more expensive over time. Then I'm going to sell it. So I'm going to take that car and I'm going to sell it in, say, 3 or 4 years' time. Or I'm going to take the equipment and sell it in 3 or 4 years' time. But it's not going to be worth what it is now. Why? Because it was used. So first of all, that getting a replacement value, because things become more expensive, is inflation. Getting the book value, what it is worth in my books, that's depreciation. So we are going to kind of make a silly assumption, is that the book value will also be the selling value, okay? The book value is the selling value. Now, in real life, that's not always the case. So you've got to look out for what the examiner tells you, for how much you can sell it. If they don't tell you for how much you sell it, then you may make the logical assumption that you can sell it for what the car or the equipment is worth. The difference between your selling price, how much you're going to get in, and how much you need to replace it, is going to be your sinking fund's value. So there is going to be the final amount that you would want to get out. Or not get out. What am I saying? That we are going to need to invest now and get in the future to replace that car. So let's start by doing an example. Now, John buys a car for $400,000. And he decides that he wants to replace the car after 3 years with a brand new car. The rate of depreciation for this car is calculated at X% per annum on reducing balance. You go and try number or letter A and B. First of all, the P value is 400,000. We know that the N is going to be 3 years, and they give me the rate of depreciation as being X. So I don't really know what X is, but I can safely assume that they're going to ask me to calculate X at some point. Okay? So let's try A and B. If the rate of inflation was 6%, inflation. So I know that is normal compound interest. Your P value is 400,000. your rate is 6% and your N is 3 years. Now, I know that some teachers, myself not included, don't like to write 6%. So 6 over 100 or 0.06. So that is your rate of inflation. So that will tell you the car is going to cost about 476,406 Rand and 40 cents after 3 years. If I look at B, now they're asking you to determine X, the rate of depreciation. So I'm going to substitute that into my reducing balance method. And A is now 100,000. So that is the worth of my car. So 100,000. The P is 400,000. And N is 3. I'm trying to get X alone. So I'm going to divide both sides by 400,000. That leaves me with 1 minus X% to the power of 3 being 1/4. At this moment, remember, I'm trying to get to that X in the bracket. So I'm going to take a cube root on both sides. And this will leave me with 1 minus X% equal to the cube root of 1/4. I'm going to do a sneaky on you. So I'm going to take that negative X to the other side and make it positive X%. In the same breath of air, so simultaneously, I love those big English words. I'm going to take that cube root of 1/4 to the other side and make it 1 minus the cube root of 1/4. And this gives me X as being 37% on the dot. Not that difficult, ladies and gentlemen, but it's all coming together in one beautiful mess called mathematics. Let's look at the next question, and this is where life becomes interesting. I say interesting, you say difficult, potato. I just love these kind of sums. So let's start by drawing a timeline. I've got a number of things that's happening. First of all, at naught, I'm going to invest 40,000 Rand. At the beginning of the second year, I'm going to invest another 40,000 Rand. Then again, at the start of the third year, I'm going to invest a further 40,000 Rand. Then halfway through the third year, I'm going to invest another 40,000 Rand. And what am I going to do? I'm going to take my interest rate, which is compounded quarterly, and I am going to ask myself, how much do I actually need to get for me to answer this question? So I need the sinking fund value. So the sinking fund value is going to be the replacement cost, which is 476,000. Remember, that's what it's going to cost after inflation. And let's make the assumption that I could sell that car for 100,000 Rand. Remember, they tell you that is the book value. Again, not realistically the book value or the market value, but let's make that assumption for now. So in other words, I am going to need 376,406 Rand and 40 cents at the end of 3 years. Whew! Let's redraw this on a new page. Because what I'm going to have to do now is I'm going to have to step by step get the value of each of those 40,000s at the end of 3 years. So this becomes a big sum. So first of all, I'm going to take the initial 40,000 Rand and I'm going to add interest, but for how many quarters? Remember, it's compounded quarterly. So if I go from 0 to 3, that is 12 quarters, because there's 1 quarter in a year. Oh man, 1 quarter in a year. What am I talking about? There's 4 quarters in 1 year. So in 3 years, there's 12 quarters. Then the next 40,000 Rand is going to be for 2 years. So in other words, for 8 quarters. The third 40,000 Rand is going to run at an interest rate of 8% compounded quarterly for 1 year. So that's going to be 4 quarters. But now what about that last 40,000 Rand? That last 40,000 Rand, for how long? How many quarters is there in half a year? Well, ladies and gentlemen, there are 2 quarters in half a year. So in other words, I'm going to put that into my N there. Get out those calculators, ladies and gentlemen. Punch these values into your calculator and get the final answer as being 181,428 and 44 cents. So this person is like way short of where they would like to go. They're not even halfway where they should be going. Because remember, they should be going to 376,000. So this person is going to have to invest a lot more money. Ladies, gentlemen, this is interestingly why the majority of us plebs, I'm just using that word, but us normal people, we don't use sinking funds because we're just struggling through every month. And then when a car needs to be replaced, we make more debt. Not the best, but this is how companies do it. If they know that they have equipment that needs to be replaced at certain intervals. So they would save up and then buy instead of loaning money from the financial institutions. Wow, I love this video. Ladies and gentlemen, I hope you loved this whole series of videos on financial maths and you enjoyed it with me. Please remember these concepts are going to build onto grade 12, okay? Or grade 12 is going to build onto this. We are building up to grade 12. That's the right words. We're building up to grade 12. So I hope you enjoyed it, and please sign in for the next series of videos, and please subscribe to this channel and get all the necessary help that you can to ensure that you master mathematics in the long run. So this is Mr. VG signing out. Keep well. Cheers.